Hi there, Year 11 General students. I'm just making this quick video to demonstrate shortest path problems, or a couple of shortest path problems. The method we're going to use for solving shortest path problems for the most part is called Dijkstra's algorithm, named after the Dutch mathematician who discovered this method. And basically it's a series of steps that if you follow, you'll discover the shortest path, or at least one of the shortest paths, through this network. It's really useful for coming up with, the shortest way to get from one town to the other if you were in a race or if you're navigating. There's lots of applications for this one. This is a bit hard to read. I'm going to move it in a second, but it's on page 419 of the textbook or on the shortest path problem page on the OneNote. So the first step of Dijkstra's algorithm is assign a value of 0 to the starting node and draw a box around the node to show that that label is permanent. So we're going to be changing the labels on each node, but once we draw a box around them, we know it's permanent. Step 2, consider all unboxed nodes connected to the node you have just boxed. Label them with the minimum weight from the starting node via the set of box nodes. So consider all unboxed nodes connected to the node you have just boxed. So that's going to be B and D. They're both connected to A, which we've just boxed. I'm going to label them both with the minimum weight from the starting node along only boxed nodes. So we're trying to get to E, by the way. We're trying to get to E. So if I want to get from A to B, the minimum way I can do that is 4, because this edge is weighted 4. There's only one way I can do it. The shortest way I can get from A to D is along this edge, which is 3. So next, choose the least, this is step 3, choose the least of all the unboxed labels on the whole graph and make it permanent by boxing it. So I'm looking at all my labels that don't have a box, choosing the smallest, putting a box around it to make it permanent. Step 4 is repeat steps 2 and 3 until the destination node has been boxed. So now we go back to step 2. Consider all unboxed nodes connected to the node you have just boxed. Label them with the minimum weight from the starting node via the set of box nodes. So this is the node I just boxed. I'm going to consider all unboxed nodes that are connected to it. That's C and E. I'm going to label C with a 5 because the shortest way to get to C via boxed nodes, it's the only way, is 3 and 2 for a total of 5. And the only way to get to E from the boxed nodes is A, D, E, which is 3 plus 7 for a total of 10. Then I repeat step 3, choose the least of all the unboxed labels on the whole graph and make it permanent by boxing it. So now I've got 10, 5 and 4. Out of those, 4 is the smallest. Put a box around it and then repeat steps 2 and 3 because this one isn't boxed yet. So consider all unboxed nodes connected to the node you have just boxed. That's these two. Label them with the minimum weight from the starting node via the set of box nodes. So this one here has got two options now. There's the 5 that we labeled previously, and this way up here would give us 6. 5's lower than 6, so we leave it. This 10 though, this 10 has, we have a new way of getting from A to this node via the box nodes. We have A, that's 4, down here, that's 5, for a total of 9. So I'm going to cross this out and replace it with 9. Then I go back to step 3. Choose the least of all the unboxed labels on the whole graph, make it permanent by boxing it. Our newest one is 5. Our smallest one is 5. And then I go back to step 2. There's only one node left now, and it's our finishing node. So when it says consider all unboxed nodes connected to the node you have just boxed, the only one's E. Label this with the minimum weight from the starting node via the set of box nodes. So if I know it takes, I've got 3 options here. I can come in from there, or from there. I know that if I'm going to go along here, 4's the quickest we can get here, and then I take an extra 5, so this would be 9. Stays where it is. This road here though, I know 5's the fastest I can get to here, and if I take an additional 3, I would have got here in 8. So I'm going to turn this 9 into an 8. And this one here is starting at 3 and taking 7, so that's 10, which is bigger than 8, so I leave it. And then lastly, we've got draw a box around the smallest one. And now that we've got step 4 is repeat steps 2 and 3 until the destination node has been boxed. So now we've boxed the destination node, we go to step 5. Backtrack through the whole set of box nodes to find the shortest path through the network. So if this 8, you have to ask yourself, which path did I take to create that 8? I didn't take this path because 8 take 5 is not 4. I didn't take this path because 8 take 7 is not 3. And I did take this path because 8 take 3 is 5. So I know that's part of our network. That's part of our shortest path. Now we've got this 5, and I didn't take this 2 here because 5 take 2 is not 4, but 5 take 2 is 3. So I know this is going to be part of it. And I only have one option there, and 3 take 3 is 0. So this is the last path. So we say the shortest path through this network is the shortest path is A, D, C, E. Perfect. So set it fairly simple steps that when you get a bit of practice with, you can do quite quickly. I'm going to do one more example now, or you can stop watching the video and get on with some of the practice from that textbook chapter 15C if you want. I'm going to do one more example here. Alright, so I'm going to go through this example. I'll try and go a bit faster this time. Went through the other one pretty slowly. So first of all, assign a value to 0 at our starting node and give it a box to make it permanent. Next, think about all the ones that are connected to that node we just boxed. Label them with the shortest possible route. This one's 2. This one's 1. Next step, put a box around the smallest unboxed label on the whole graph. That's F. Then consider ones connect to F, that's G and K, and label them with their shortest possible route. So that's 3 and 5. Next, put a box around the shortest one, smallest one. Then label the shortest route to each connected to that box we just did. 2 plus 3 is 5. 2 plus 3 is 5. Because 5 is bigger than 3, we won't do that one. Well, we'll leave that one as a 3. Because 2 plus 3 is 5, bigger than 3. Smallest number on the board, this 3 there. What's connected to 3? Well, you've got a 3 here, so that would be, we know that 3 is the fastest you can get here, so that would be either 6 or, oh no, that one's not boxed, so we don't use that one. 3 plus 3 is 6. 3 plus 5 is 8. Smallest one here, well, looks like we've got 2 5s. Let's use this one. I think you can choose either one if it's a tie. There's only one attached to this box node. So we ask, what's the fastest way we can get there? Well, that's where we got our 8 from. But if we came from here, K, took a further 2, got to L, that would only take 7. So I'm going to cross that out, replace it with a 7. Now, look for the smallest labeled node. That's this 5. Box it, make it permanent. Look at each one connected to the most recently boxed node and go, what's the shortest way we can get there? So 5 plus 5 is 10. 5 plus 6 is 11. 11's bigger than 6, so we'll leave the 6. Box the smallest unboxed label. Once a label has been boxed, assign values to each label next to the box. 6 plus 2 is 8. 6 plus 1, 7. Next, we're going to box the smallest node. I'm going to do this one here. There's only one connected to that. 7 plus 2 is 9, which is bigger than 7. So we're going to leave that one as a 7, which is now the smallest on the board. So we box it. 7, this node here, M, is only connected to this node here, N. The shortest way we can get to N via the set of box nodes is 7 plus 4. So we mark that with an 11. What's the smallest one now? This I. What's connected to I? Well, we've got 3 connected to I now. So how could we get to this D? That would be 8 plus 2 is 10. So that stays the same. 8 plus 1 is 9. 8 plus 2 is 10, which is smaller than 11. So we cross that out, replace it with a 10. What's the smallest one on the board now? Looks like this 9. What's connected to 9? Well, we've got our finishing node. 9 plus 4 is 13. 9 plus 3 is 12. Next, we're going to box the smallest node on the board that it doesn't have a label, doesn't have a box yet. So I'm going to box this one, and then 10 plus 2 is 12, which is less than 13. So I'm going to replace this 13 with a 12. Repeat the other step. Box the smallest node. Once you've boxed the smallest node, label all those connected to it. D plus 2 to get to E is 12. 12 stays the same. Next step, box the smallest node. Well, we've got 2, but this one's the one we're aiming for, so let's box that. And we're done. We've boxed all the nodes. We've boxed the node that we're aiming to get to. So now we can go on to the last step, step 5, and work out our backtrack through here. Get a slightly different color. So 10 take 12 take 2 is 10. 12 take 2 is 10, so now it's 3 there. 10 take 4 is 6, not 7, but 10 take 2 is 8. 8 take 2 is 6. 6 take 6 is not 5. 6 take 3 is 3. 3 take 2 is 1. And 1 take 1 is 0. So that means the shortest path is A, F, G, H, I, N, O. Perfect. Thanks for watching. Good luck.